Robot Talk is the podcast that sits down with roboticists from around the world and asks them the questions you always wanted answered. Like, can the robot climb stairs? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week's episode is all about bipedal robots and how roboticists are using clever maths and taking inspiration from humans to help robots overcome the challenges of moving around human environments on two legs. But first, I'd like to remind you to rate this episode and leave a review, if that's something you can do on the platform you're listening on. Another way to support the podcast is to share new episodes on social media or tell your friends about it. It really helps me reach more listeners, so thanks in advance. So, without further ado, I'm excited to introduce this week's guest. I recently had a fun chat with Oluwami Dosunmu-Ogunbi from Ohio Northern University about bipedal robots that can walk and even climb stairs. Today, I'm talking to Oluwami Dosunmu-Ogunbi, an assistant professor at Ohio Northern University working on control algorithms for two-legged robot movement. Hi Wami, welcome to Robot Talk.
Great to be here. Thanks for having me.
You know, robots come in a really wide variety of different forms, different shapes, and each one has different uses and challenges. So to get us started, what made you decide you wanted to work with two-legged robots?
Oh, that's a fun question. So I actually have two responses to this. I have my PR answer and I have the actual answer.
Okay.
So I'm going to give you both. And let's start with the PR answer. So we live in a world that's built primarily for two-legged beings. And while accessibility is always a goal that we want to strive for, there are advantages of building robots that can navigate our current environments. So anywhere that a human can go, anything that humans can do, we want our robots to do. Mm-hmm. And the reason for that is, at the end of the day, we want to make human lives easier. So offloading dangerous and boring tasks to robots so that the humans can do the fun and safe stuff.
Yeah, absolutely.
So yeah, that's my PR response.
Yeah, sure.
But the actual answer is because I just fell into it. So even 10 years ago, I probably couldn't have told you what field I was going to be in or even what research I was going to study. Mm. I did some undergraduate research in 3D printers, and that ended up being my first research topic when I went to grad school. And then I briefly went to qualitative research at some point. I was doing things like studying design fixation and design processes and all that stuff. Mm-hmm. And things didn't work out in that program. So I ended up moving into the robotics program at the University of Michigan. And it was very unusual circumstances because my new advisor was stepping in to get me back into a PhD program after being kicked out of my first PhD program. Okay. So his research was in bipedal robots. So that's what I decided to study because, that's his expertise. I was just grateful to be back in a PhD program.
Yeah, absolutely. It sounds like you're a little bit like me in the sense that you're just kind of fascinated by everything. It makes it really hard to narrow down your field.
Exactly, yeah.
So your PhD research, as you said, focused on bipedal robots and specifically getting them to climb stairs. So what makes that a challenging task for this kind of robot, and how did you approach that problem?
Yeah, so if you think about how humans walk, we would put one foot in front of the other, and depending on how close or how far we place that foot, that would affect things like, our speed and our balance, and especially if you don't change anything else about your gait, so like where your center of mass is. So with stairs, you're limited with the area that you can place your foot, which means that foot placement alone is not an ideal metric to climb stairs. Mm-hmm. So up until that point in my lab and in similar labs, we would ignore a robot's ankle motor. We'll just make that motor zero, essentially. So you can think about yourself if you ever tried walking without using your ankles.
Just kind of locking your feet.
Yeah, exactly. Yeah. It's doable, but it's, very awkward.
Yeah.
So now you can try doing this on stairs, which is probably closer to impossible.
Yeah.
So, in my research, one of the novel contributions that I was doing was figuring out a mathematically optimal way to use that ankle to get that robot to climb stairs. And another example for humans, as we're walking, we usually keep our torso maybe the same height as we're walking. So in our research labs, we would often make the assumption that the robot's center of mass, which I'm kind of hand-wavily making it equivalent to our torso, a little bit more complicated than that, but so basically keeping our torso the same height. So if you're walking on flat ground, that's a great assumption to make, and it makes our equations a lot simpler, makes the computation a lot faster. But if you're walking upstairs, well, obviously your torso is moving, right? It's going up the stairs with you. So that was another mathematical equation that I had to incorporate to make stair climbing possible.
Mm-hmm. Okay. So, a lot of roboticists take inspiration from biology, from what real creatures do. With bipedal robots, you've got a really close analogy with humans. How much time did you spend looking at how humans climb stairs to kind of give you inspiration for this?
So one of the fun things about working in a bipedal robotics lab is that anytime any of the students are trying to figure out how to get our controller to work or a way to incorporate something that's bio-inspired, we would just get up and just start walking and just looking at ourselves as we're walking. Or we will tell our friends get up and just start walking so we can look at what they're doing. And we'll gain inspiration from that. And in some sense, we'll also maybe look at some bio-inspired literature as well. But the best subject is ourselves. So we would look at what we're doing and then try to incorporate what we're seeing into those algorithms.
Yeah. It's a lot easier when you've already got people around that you can just, like you said, just ask people to do stuff. Whereas I guess roboticists who want to take inspiration from birds have to actually go outside and find some birds.
Yeah, and they're flapping really fast. So that's harder to monitor. So
yeah, absolutely.
Humans are great muses.
Kind of on this same topic, we had an audience question from Pencil Sketchy on Blue Sky, who said, are there any practical real-world applications for two-legged robots, given that we've already have treaded robots that can traverse stairs and that don't fall over in the event of a sudden power or system failure?
Oh, yes. So I love this question. So I think in the field of robotics, we sometimes can fall into the trap of saying which robot type is the best one. And I'm of the opinion that there's no one robot type that is better than the rest. Each robot can be useful for different tasks depending on what you're trying to do. So for example, drones, they're very great and they can fly over all the mayhem and fly over debris if there's a bunch of things on the ground and stuff like that. But at the same time, they tend to have shorter battery lifespans. Then you have things like wheeled robots that can go super fast and are super stable. But things can get trickier as you add more, obstacles in your environment as things get a lot more cluttered. Not to say that's impossible because there's been a lot of good advances in wheeled robots. But things slow down as things get more cluttered. And then you got quadrupeds or four-legged robots. These are a lot more robust than humanoids or two-legged robots because they can navigate in more space-constrained environments, but they can have limited reach compared to the humanoid robots. And then humanoids can theoretically occupy any space that any human is able to, and they can also theoretically do any task that humans can do. But of course, as a con, they can be harder to balance and they're not as fast as wheeled robots. So think about the problems that you're trying to solve or what tasks that you're trying to accomplish. And then you can pick a robot type that is best suited to accomplish those tasks.
Yeah. When I picture your stair climbing robots, I think of them being in my home or whatever, because I've seen a lot of these kind of home care, social care robots, and most of them at the moment have wheels and kind of just wander around the first floor of your house being helpful, but as soon as anything's upstairs, they're like, sorry, you're on your own now. Is that where you see these legged robots being primarily used?
Oh, yes. I think that's an excellent use case for the humanoid robots. So, yeah, going back to what was mentioned earlier in the interview, where we want to give robots these tasks that will help make human lives a lot easier. So the home is a great use case of an environment that is usually built for two-legged beings. So a two-legged robot can theoretically navigate any sort of situation in there and help out around the house, help fold laundry, help wash dishes, help in-home care, things like that. Help patients. So yeah, I see excellent use cases there. And I think that's definitely one of the goals of the field.
Mm-hmm. So, I mean, Pencil Sketchy hits on quite an important issue here of what happens to a upright legged robot when the power gets cut. Because, you know, traditionally, I think our idea of safety with robots is if something goes wrong, just turn it off. But of course, with a bipedal robot, it could fall, it could hurt you, it could damage itself or other things in the surrounding area. How do you think we should address safety for this form of robot?
Yeah, excellent question. So part of the, I guess, ways that one can accomplish this is just integrating them in the control algorithm. So, for example, if the robot senses that it's about to lose power, or if it senses that it's about to tip over or something like that, it will trigger a failsafe such that it will take the path of, the safest falling.
Mm-hmm.
So we see this, for example, in drones. Would see that if a battery is about to lose power, it's going to do a controlled descent.
Yeah.
So bipedal robots, especially some of the ones that I worked with, they already have some of this integrated where if it's about to fall or something, it's going to do things like put its hands out such that it can control its descent down. And so it catches itself with the hands and then it will lower itself to the ground. And then some even more fancier algorithms will have a nice way of getting the robot to stand back up in a safe, least chaotic way. Definitely there's progress that can be made to further improve these algorithms, but that's the, direction that we're going in. So that's the algorithmic side. I would also say that to give people more, peace of mind too, these are things that also exist, big red buttons, essentially, that humans, any person that's nearby, they can hit a button and the robot will stop. So one of the robots that I worked with, Agility Robotics Digit Robot, it literally had a giant big red emergency button that the person, the operator, can walk around with. And whenever they hit that button, all the motors of the robot will just immediately shut off. So yeah, things like that can also help.
Mm-hmm. I don't know if you've seen the film Big Hero 6, but I think...
I love that movie.
Yeah. I just think if we had inflatable robots, then it wouldn't matter if they fell over.
Yes. Oh my gosh. I want to build a Baymax so badly, just so I can have that big hug.
Yeah.
In fact, I want to change my first answer from before. Why two-legged robot so that I can build a Baymax?
Yeah. Perfect. Yeah, I spoke recently to some people who've been doing some research on hugging robots and what the experience of hugging robots is. But they are not like Baymax robots, and they clearly should be.
Yes. Oh my gosh. It's a giant fluffy marshmallow that can it has a little heated pad and everything. Yeah. Love it.
So I've definitely experienced in my podcasting that robotics is not the most diverse field. And, as the first Black woman to earn a Ph.D. in robotics at the University of Michigan, you are probably even more acutely aware of this than most. But this lack of diversity has really important real-world consequences. And I watched your wonderful TEDx talk on how to prevent the robot apocalypse. And in that, you talked about how a biased human will develop a biased robot. But we don't have access to any unbiased humans. We're all biased. We all have blind spots. So to kind of avoid imprinting those biases on robots, obviously it's really important that they are developed by diverse teams. I know this is a topic you're very passionate about. What do you think are the most important steps towards increasing diversity in robotics?
Oh my gosh, yes, that's such a great and such an important question. And as you said, I am definitely very passionate about it. At the end of the day, I think humans, for the most part, we love and we want to help each other out. But, we're also very much limited by our own humanity, that we all have our own faults and our imperfections. And as much as we might try to get rid of them, we still have our biases. Yeah. And while we try to mitigate those as much as possible, we know that it's impossible to eliminate it on an individual level. So that is why, we need each other. It's actually another beautiful part of humanity that we're social beings and we rely on each other to help us be collectively the best versions of ourselves. So like one person's faults can be overcome by another person's strengths.
Yeah.
One person's blind spots can be alleviated by another person's experiences. So that's why we need diversity in fields, especially like robotics. So I know that, for example, the engineers out there probably did not mean to have self-driving cars have a harder time to detect, Black people. But if you look at who is on the team, then maybe they didn't have the perspective to test the safety of their systems with, like Black users, for example.
Yeah.
But if they had more diversity, maybe they would have had a more broader test cases. So how can we achieve this? How can we improve diversity? Well, you can think about we can do outreach, so get students while they're young, but also not fall into the trap of focusing only on affluent schools. We want to make sure that we're reaching schools, especially the ones that are under-resourced as well, because there's a lot of untapped potential there. And then I also have a controversial take.
Okay.
Things like DEI, so diversity, equity, inclusion, is something else that can help us achieve this goal. Now, I also preface by saying that there's honest criticisms of DEI, where in some applications of it, you might fall into the trap of, well, if the system was originally built for, rich white males, we fall into the trap of now only looking at rich Black people. So that's obviously something that we don't want. We want people from all socioeconomic backgrounds. But at its core, at its best, DEI strives to give opportunities to students who, despite being capable and qualified, they don't get the same opportunities as the people from rich and well-connected families. So in other words, it's trying to get us closer to a meritocracy. Yeah. So one might say that, well, aren't we already in a meritocracy? And I would push back against that. One of the most obvious signs to me is a very personal one. As you brought up, I am the first Black woman to get a Ph.D. in robotics at the University of Michigan, which is a huge state school. Do I believe that I'm the only Black woman in the entire state of Michigan that is capable, qualified, and want to get a PhD in robotics? I don't. Well, actually, I'm not even from Michigan. I'm from Alabama. So I guess, yeah. So I guess the question becomes, why am I the first and why am I the only one right now?
Yeah.
And also, why is this a common statistic across the overwhelming majority of schools in the United States? So I don't want to keep picking on Michigan, but this is something that we see everywhere. So there's this huge pool of untapped talent from people from these underrepresented groups. So how do we leverage this untapped talent?
Yeah, absolutely. And I think, you touched on an important point there. It's obviously not just race that is important in terms of diversity, like socioeconomic backgrounds, gender, like everything, because all of those people have different lived experiences and can bring something different to the table, right? Like you said, if it's exclusively rich people who are roboticists, they have their own blind spots, particularly about what, like normal people actually need and want.
Exactly. Yes.
But I'm sure there are others as well. So yeah, it's across the spectrum. It's just we need people from all walks of life to be roboticists. Yeah,
absolutely. I like to think about what type of problems do we want to solve for our robots? Well, the people who get to answer those questions are roboticists. So who are those roboticists? And are they helping every person? And I truly, genuinely believe that if we have a roboticist that are looks like the world that it serves, then we will have robots that will be able to better serve humanity.
Yeah. It's a challenging problem, though, because obviously one thing I think that really helps is for children to see people who they see themselves in as role models, right? But when you have an undiverse field, there aren't very many of those role models available. And something I'm very conscious of as a podcaster is that those few role models who exist then get this huge burden of responsibility, of time, commitment, of everything to have to put themselves out there. And then they want to do that usually, but human beings have only so much time and so much, there's a limit to what people can do. So you kind of end up with this bottleneck of not wanting to overexploit those role models who already exist, but desperately wanting to show people that they are there. It's a tough balance.
Yeah, absolutely. And definitely one way to help this is like, yes, doing things like giving people like me a platform to be able to share the message to a more broader audience is definitely very helpful. So thank you so much for inviting me to this podcast. But yeah, also being careful not to, as you were saying, like overtax, overburden these people. I remember, so shortly after graduating, I did 3 big commencement speeches at the University of Michigan and went a little bit viral, especially in the country of Nigeria, which is where my parents are from. Was very grateful for that. But then I had a lot of people reaching out to me and asking a bunch of things. And during my undergrad and grad school, I would say yes to a bunch of things. Like outreach events, things like that, happy to do it. But at the same time, I'm a human, only one person. Exactly, when those requests start to get into like the hundreds, I was like, I'm trying to find a job at that point too. So I need to pay some bills. So I'm happy to help however I can. But at the same time, I guess I'm also saying this to myself. I am one person, so I can't say yes to everything. So any way that people, allies, supporters can, help support us, that is greatly appreciated.
Yeah, it's an important mantra to keep saying, I have to say no to some things. I cannot do everything.
Oh, yeah.
So, but you've certainly been busy because recently you've been developing the Bipedal Bootcamp, which is a technical document and a series of lesson plans to introduce students to bipedal robotics. So can you tell us a little bit about this project?
Yes, I would love to. So, okay, one thing about me is that I am an avid note taker. Okay. So as I was starting in my new Ph.D. program with my new advisor, I was going through what our lab would affectionately call the Biped Bootcamp. So this is something that was created by my PhD advisor, and it was a series of verbal one-on-one lectures that he would have individually with each of his PhD students as they were starting out in his lab, to ground them in the fundamentals of how bipedal robots work. So while I was going through that bootcamp, I was documenting everything. Like I said, I'm an avid note taker. So I was writing things down as I was learning them. I would ask further questions to my lab mates, I would do additional research to answer any additional questions that I would have, all while writing these detailed notes. And the way that my brain works, I decided that the best way or the best form that these notes should take would be in book form. So it's something that I could easily reference whenever I got stuck later down the road. Well, my advisor saw what I was doing, saw my book, and he said, "This is good. You can teach students with this." And so I was able to recruit some undergraduate students, mostly freshmen. There was like 5 or 6 of them initially, and then led them through the Biped Bootcamp. And they were able to do the exact same things that I, as a then second year PhD student, didn't see for the first time until that point in my graduate school studies. They were now doing as freshman students. So it showed like the accessibility of this document that I wrote, the audience that it can reach out to. And one of those students ended up teaching students of her own using that same document. Cool. And one of her students was a high school, I want to say junior or a senior. So again, showing you the audience that it can reach. And because one of my goals is to make robotics, more accessible to more people, it just made more sense to me that the next logical step for this Biped Bootcamp is now to convert it into something even more accessible. So I'm thinking like a series of lectures that I can probably put online, some exercises that people can work through, maybe some workshops. Things that are usable to anyone that's interested in learning about bipedal robots. So currently still focusing on, I guess, like more the undergraduate realm, but I also want to make sure it's accessible to people who are not even in college too, who are probably interested in robotics, but they don't want, the whole 4-year degree.
It's fantastic. What an incredible resource. I think it's really cool because I obviously have never experienced the educational system in America, but I'm assuming it's not totally dissimilar to the UK. I find quite often at, high school level and the first years of undergrad, it can all seem a bit abstract and you have to wait till the final year or the third and fourth year to really see all the cool stuff. And so giving them a little bit of a kind of window into what they can look forward to maybe will give them that push to stick out the kind of the fundamental kind of boring necessary theory that underpins it all.
Exactly.
Get to the end.
Yeah. So by the end of the bootcamp, they would have already created their first bipedal robot in simulation. So they get to see the fruits of their labor walk across the screen. And I forgot to mention, so another thing that I'm working on is like creating the hardware version of this robot. So again, in the theme of accessibility, I want to be able to make this platform that's something that people can easily find the materials for, that's low cost, easy to assemble, so they can take the robot or the controller that they created in simulation and now put it on this robot that they're also able to build. Build.
Cool.
So yeah, I think people would really enjoy that.
Yeah, I want to do this Bipedal Bootcamp.
Yeah, absolutely.
So it seems like humanoid robots are having a bit of a moment right now. You know, it's barely a day goes by without going on social media and seeing some video of the latest humanoid that's everyone's excited about. And people are kind of talking like humanoid robots are going to do everything and take over everything and change the world. What are your thoughts on all of this?
Oh my gosh, yeah. I think we've barely scratched the surface. Like, there's so much potential that humanoid robots have yet to unlock. And yes, you're right. Humanoid robots, they're definitely going through a moment. A lot of money has been poured into the industry, which I'm very grateful for. I hope it keeps up so that we can really reach that untapped potential. If I even think about like the last 5-10 years, the difference between like those early robots, like where we are right now, it's just incredible. Like the stability of the robots. We now have robots that are able to like box, robots that are able to do like soccer tournaments versus several years ago, balls being hurled at a robot that would easily just break the entire system. But now the robots are able to hold their own. And I think we'll see even more robustness here. You mentioned, I think that there's some robots that we're starting to see in the homes. There's definitely at least one company out there that is starting to sell their robots for home care. I do think it's a little bit premature for that, only because from what I've seen from videos and interviews of these robots is that it looks like it's still heavily relying on teleop. So like an external person controlling the robot remotely. And the things that it can do autonomously, it's still kind of awkward. But I genuinely believe that we're on the right path to like do more and more tasks more autonomously, a lot faster and a lot more robustly. In fact, that's like my vision for the next 5 to 10 years. I'm pretty sure at the rate that we're going, we definitely have the capability of being able to do even more tasks faster and autonomously.
Yeah, it is incredible. Some of these videos I've seen, I'm like, that's not a robot. That's a person in a robot suit. It has to be. There's no way. I'm kind of equal parts excited and skeptical because I watch all these videos and I'm conscious that they are marketing material. And it's not always that clear how much is autonomous and how much is pre-programmed teleoperation, whatever. Like I said, equal parts skeptical and excited, I think.
Yeah, or like having a controller that's really good at doing like one task. It's able to do like this dance because it's choreographed and pre-programmed. And just to clarify, these tasks, these very fancy movements, they would have been unheard of, not too long ago. So it's impressive that we're even doing that now. But yeah, there's still a lot of ways to go. And I can appreciate the idea of wanting to market the robots to do a little bit more than they're kind of capable of doing now, just so that we can keep getting money funding for it, so that we can eventually get to those higher goals. But yeah, still some work to be done.
Absolutely, yeah. I mean, a robot that can dance is cool, but what I really want is one that can fold my laundry and do the washing up for me and stuff like that. Which we're not quite there yet, but soon, hopefully.
And a Baymax, yes.
Yes, and that's on the wish list as well.
Exactly.
Wami, it's been lovely chatting to you today. I've been speaking to Oluwami Dosunmu-Ogunbi from Ohio Northern University. Thanks, Wami.
Thanks for having me.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. And check out @Robot Talk Pod on social media to see a photo of 2 Agility Robotics bipedal robots, Cassie Mays and Cassie Blue, at the University of Michigan. Next week, I'm chatting to Stefano Minchev from ETH Zurich about robots in the environment. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk Season 6 is sponsored by the Hamlin Centre, Imperial College London.